In this video here, we're going to look at the behavior of rational functions near positive and minus infinity. I'm going to do a couple problems for you and explain how these work. So let's do this. Here we have this rational function you see here, 9x to the fifth minus 2x cubed plus 1, all divided by x to the eighth plus x plus 1. And to analyze this function near plus or minus infinity, there's a little trick we always do, and it's going to be this. R of x equals, factor out the biggest term, that is up here. We'll factor out 9x to the fifth. Get 9x to the fifth times, I need a 1 there to get my 9x to the fifth back. Alright, and now I need to get 2x cubed back. So what am I going to need? When I multiply, let's see, so to get the x to the fifth, x cubed back down here, I need an x squared. Alright, and to get the 2 back, I need a 9 down here to cancel that 9 and a 2 up there. I think that'll work. Think about when this thing distributes back through. And then plus, when you have a constant, it's always just 1 divided by whatever you factored out. Okay? Now on the bottom, I need to factor out the highest term there, the highest power, x to the eighth. So x to the eighth times, I need a 1 there to get my x to the eighth back, plus, and I need to get x back. So what's that going to be? 1 over x to the seventh. That will get my x back when the x to the eighth distributes back through, plus 1 over x to the eighth. Now a lot of students have trouble with this portion of it. You got to check yourself. Make sure that when you look and check yourself, make sure that when you distribute, you get your original function back. That's 9x to the fifth. Distribute here, and when we get the 9's cancel, the x to the third, and I get my 2, and distribute there, and we get our 1. Okay? And when we distribute on the bottom here, I get my x to the eighth back. Here, the x to the seventh gives me x. Here, the x to the eighths cancel, and I get that. So here's the trick now. We see this, so we get that our function then, as x goes to plus or minus infinity, we see that these terms here, what's going to happen to that term as x goes to infinity? What's 2 divided by 9 times a googolplex squared? Well, that's going to be 0. That thing's it's going to get as close to 0 as we wish as we make x bigger. Same thing here. That term is going to go to 0, so it's gone. Now, on the bottom here, the 1 over x to the seventh. As x gets really, really big, it's going to 0. Here, 1 over x to the eighth. As x gets really, really big, that term is going to 0. So then we can say as x approaches plus or minus infinity, r of x is approximately equal to what's left over. And so when we distribute here, we get the 9x to the fifth and x to the eighth. That is, as we distribute over here, there's going to be 9x to the fifth essentially times 0. And so it's going to give us 0. And the same thing here, same thing here, same thing here. So r of x is approximately equal to 9x to the fifth over x to the eighth, which equals, what's that going to be? 9 over x cubed. Okay? So now let's look at this as let's look at plus or minus infinity individually. Then as x goes to positive infinity, we see that r of x is going to approach 9 divided by googolplex cubed, it's going to be 0. But I'm going to, for you guys going to calculus, I'm going to use a little notation here. I'm going to say 0 plus. And that's going to mean it's going to go to 0, but it's going to be a really small positive number that's getting closer and closer to 0 on the positive side. Let's see if I've used all my colors. As x goes to negative infinity, we're going to see that r of x goes to, when I go to negative infinity, this x cubed down here, that's going to be a big negative number. So r of x goes to, we'll say 0 minus there. And that's going to mean that it's going to 0, but it's on the negative side. Okay? So, let's look at a graph of the function. Here I've graphed our function, and we see here that, so here it is, as x goes to infinity, we see here we're approaching 0 on the positive side. Okay? There we go, 0 plus. Okay? And over here, as x goes to negative infinity, we see we're approaching 0 still, but it's negative numbers that are approaching 0. Okay? Let's do another one. Here I've got the function r of x equals 3x to the 6 minus 9x to the 4th plus 5 divided by the polynomial on the bottom there. You see it? And so I want to, r of x equals, let's factor out the term with the highest power, 3x to the 6th. Alright, I need a 1 to get my 3x to the 6th back. And let's see on the bottom here, I need x to the 4th back, so I know I need an x squared there. And I need a 9 to come back, so I'm going to cancel the 3 here and put a 9 up there. Even though that would reduce, I'm going to leave it like that so it's clear that the 3's cancel, and it leaves me with my 9x to the 4th. Anytime we have a constant, you just divide by what you factored out. All divided by, here, I'll factor out that term, 2x to the 6th times, I need a 1 to get my 2x to the 6th back. I need to get a 4x back. So on the bottom I know I'm going to have an x to the 5th. I'm going to cancel that 2 when it distributes back, and I'm going to put a 4 up here, and that will give it back to me. Plus 3 over 2x to the 6th. Okay? And so we're going to come down here and see that our function r of x, well, we can go ahead and look at the limits. Again, if we look at the limit, or look as, let me say, as x approaches plus or minus infinity, we see that this term here, as x gets really, really big, that's going to 0. As x gets really, really big, that term is going to 0. As x gets really, really big, that term is going to 0. As x gets really, really big, that term is going to 0. So as x goes to plus or minus infinity, r of x is going to be approximately equal to 3x to the 6th over 2x to the 6th. See, those x to the 6th are going to cancel and get this is equal to 3/2. Okay? So, let's look at this on the graph. So look at our graph here. I use Mathematica to plot this graph, and we see here that as x goes to infinity, here it is, so we see here that we're approaching 3/2. This thing is going to get closer and closer to this line, 3/2, as we go to infinity. And on the other side, as x goes to negative infinity, again we see that we're approaching that 3/2.